and then bone resorption and absorption. So osteogenesis is bone development or bone creation, and ossification. So basically, when we were in the embryo, and I've talked to you guys about this before, when we were in the embryo, we were mostly hyaline cartilage. Now, that doesn't mean that no bones developed while we were in the womb, but not all of our bones ossified, which mean turned from the hyaline cartilage into bone. And so when we were actually born, we were hyaline cartilage and bone, and then we eventually go through a period of total ossification where we will continue to replace hyaline cartilage with bone until early adulthood. So you guys are actually still in that growth phase where you have something called an epiphyseal plate that is still the hyaline cartilage that is still growing and extending your or the length of your long bones so that you can still grow. And then we're going to get into remodeling and repair a little bit later. So the formation of the bony skeleton begins about week 8. So again, we start out as all hyaline cartilage, and then some of that cartilage ossifies or becomes bone over time, not all. So when we're born, we're bone and hyaline cartilage. So there's two types of ossification. There's intramembranous ossification and endochondral ossification. And so intramembranous is going to be the type of ossification that happens in the skull and the clavicle. Endochondral is where we're going to replace that hyaline cartilage to form all of our other bones. So postnatal growth, meaning that you are out of the womb, we have cartilage still on the side of the epiphyseal plate closest to the epiphyses. So where we have the diaphysis in the middle of the bone, we have the epiphyses on the end. And when we have these epiphyses, between the diaphysis and the epiphyses is hyaline cartilage. And that hyaline cartilage is still able to allow for bone lengthening. So cells of the epiphyseal plate proximal to the resting cartilage are going to be undergoing growth. So there are different zones in long bone. So the growth zones are the cartilage cells that are undergoing mitosis. That's going to push the epiphyses away from the diaphyses, but when it's pushing, it's going to also be ossifying. So there's going to be a portion that's, as it's lengthening, it's going to turn into bone, and you're still going to end up with that growth zone attached. Then you have a transformation zone. So outside of the growth zone, that's when those cells are becoming ossified, and then osteogenic, that's when the new bone is going to form. In this diagram, you can then see it, and when you're looking at this, this should look familiar. This looks like cartilage. These are those lacunae with the chondrocytes in there. And so we have the growth zone. These cells are undergoing mitosis. They're pushing. You can see that it looks opposite because it looks like they're growing down, but they're pushing this way. And then we're calcifying here, meaning that we're actually starting to bring calcium in and replacing the chondrocytes with that calcium for the matrix. And then finally, we're actually making new bone at the bottom. Now this resting zone is still there. So you can see up here what we're looking at. And this is the epiphyses, this is the diaphysis, and then here we have that epiphyseal plate, and that's where all of this is undergoing its change. Now, at my age, I am no longer growing, so my epiphyseal plate, where it was, or growth plate, as you guys have heard it, it is no longer hyaline cartilage. Instead, it is now ossified. So it no longer is undergoing mitosis and growing. But all of your growth is still going on, and it is based on growth hormone and testosterone and estrogens, which are also hormones. And so what these hormones do is they initially promote a growth spurt, and some of you guys had large growth spurts, some of you guys had smaller growth spurts, and they cause the masculinization or feminization of specific parts of the skeleton. So women get more rounded hips, men get more narrow hips, women's jaws tend to be more rounded, men's jaws tend to be a little bit more chiseled, I guess. And so all of these hormones are allowing us to then develop into female and male individuals, and also growing of those bones. And then it says later induce epiphyseal plate closure. So later in life, your epiphyseal plates will totally ossify, and you are left with something called an epiphyseal line. Now, there are a couple of different cells that I talked about at the beginning of this chapter, and we're going to go into a little bit more detail on this. If you don't totally understand this part, I'm going to go over this with you. But the resorption of bone means that you are taking bone, or basically the matrix of the bone, out of your bone itself. So resorption means you're bringing anything in the bone out. So we're breaking down the bone matrix, and we're going to then release it into the bloodstream. So osteoclasts are the bone or the bone cells that are going to be doing this, and they have lots of lysosomes, because if you remember, lysosomes can break things down. So they're going to go in, they're going to use acids, they're also going to use enzymes to actually break down the calcified matrix and be able to put it into a soluble form where it can get into the bloodstream, and then that calcium can go into the bloodstream and do what it needs to do. So this is just saying the same thing basically as that dissolved matrix. So we've dissolved it with those osteoclasts, and now it's going to be secreted into the interstitial fluid, which is the fluid outside the cell, and into the blood to be delivered. And calcium is very important for a lot of different things in your muscles, in your body to happen. Calcium is necessary for nervous impulses to be transmitted, muscle contraction, it's very, very important for that, blood coagulation, secretion, and also cell division. There are two different loops. We have a negative feedback mechanism that regulates calcium blood levels. And so what we're doing when we're releasing or absorbing the matrix of the bone, we are just allowing for enough calcium to be in the bloodstream at all times. We have to maintain a certain level of calcium to maintain homeostasis. So this is what I'm going to talk to you guys about in a little bit more detail. But anytime your blood calcium raises, so you have too much calcium in the blood, you have a thyroid gland that's going to release calcitonin, and that's a hormone. And this calcitonin then is going to say, okay, we have too much calcium in the blood, we need to put it back into the bone. So we're going to put those calcium salts back into the matrix of the bone. And this is going to happen, or the cell that's going to make this happen is called an osteoblast. Now, in this case, when we don't have enough calcium in our bloodstream, we have a parathyroid gland that releases parathyroid hormone. And that parathyroid hormone tells the osteoclasts to go in, degrade some of that calcium bone matrix, and release it back into the blood to maintain homeostasis. And this is just the negative feedback control loop that we've seen a couple of times in class.